Hello students, welcome back to this lecture series of M.Sc. Part 1 Mathematical Methods in Physics. In the last class we discussed the recursion relations of the Lagrange functions. Here these three relations, that is first one, that is we already discussed in the last class. Okay, now in this lecture we are going to discuss the second recursion relation, that is L prime n minus n into L prime n minus 1 plus n into L minus 1, and this L, that is a Lagrange polynomial, the function of x. Okay, and this is a third recurrence relations, x into L double prime n plus 1 minus x into L prime n plus n into Ln. Okay, so here we are going to discuss the second one, that is L prime n x minus n into L prime n minus 1 plus, okay, this is a function of x, so plus n into n minus 1, which is function of x equal to 0. Okay, so here we are going to use the relation between the Lagrange polynomials and the generating functions. So we know the relation e raised to minus xt divided by 1 minus t is equal to 1 minus t summations over n is equal to 0 to infinity ln x into t power n by n factorials. Okay, these relations that we are going to use, this is a generating function of the Lagrange differential equations, and this ln x, that is a coefficient of the t power n by the n factorials. Okay, now here if I differentiate with respect to x, okay, then we get minus t by 1 minus t e raised to minus xt divided by 1 minus t is equal to 1 minus t summations over n is equal to 0 to infinity. This ln x, this is a function of the x, so that's why it differentiate with respect to the x, so it is L prime n x divided by n factorials into t power n. Okay, this is a differentiate of these relations with respect to the x. Now these expressions we can replace with this thing, so it is minus t by 1 minus t summation 1 minus t summations over n is equal to 0 to infinity, and it is ln x n factorial into t power n is equal to 1 minus, or just multiply to this bracket, so it is summations n is equal to 0 to infinity L prime x divided by n factorials into t power n, and the minus this t and here t power n, so it is, we can write summations n is equal to 0 to infinity L prime n x divided by n factorials into t power n plus 1. Okay, and here this t 1 minus t will be cancelled out, and this minus t, or this t power 1 and this t power n, we can write that t power n plus 1. Okay, so here this on the minus sign. Okay, now we have these expressions. So if I write, so it is summations n is equal to 0 to infinity ln divided by n factorial into t power n minus L prime n summations n is equal to 0 to infinity L prime n is function of x divided by n factorials into t power n plus summations n is equal to 0 to infinity L prime n divided by n factorial into t power n plus 1. Okay, here is also t power n plus 1. Okay, now we want here t power n only, so but here t power n plus 1, so for that we need to replace this n with the n minus 1. Okay, so if I replace n with the n minus 1, so it is l n minus 1 is function of x divided by n minus 1 factorials and t power n for these summations. Okay, and minus l prime, here is the t power n by the n factorials. Okay, so no need to replace, into t power n by n factorials. Okay, and here is also t power n plus 1. Okay, so same thing here is also, we need to replace n by the n minus 1, so it is l prime n minus 1 divided by n minus 1 factorials into t power n. Okay, so it is equal to 0. So here is also t power n and the t power n, but here n minus 1 factorial, so we can write this is n by n factorials, and here is also n minus 1 by n minus 1 factorial, so it is n into n by n factorials. Okay, so now just equate the coefficients of the t power n by the n factorial, so it is n into ln minus x minus l prime x plus n into l prime n minus 1 is function of x is equal to 0. Okay, so this is the second recursion relations. Okay, so if I rearrange this thing, so it is l prime nx minus l n into l prime n minus 1 plus n into l minus 1 x is equal to 0. Okay, so this is the second recursion relations of this Lagrange differential equations. Okay, so now we are going to try to solve the third one. So third recursion relations is x into l double prime nx plus 1 minus x l n l prime n x plus n into l n x is equal to 0. This is x. Okay, okay, right. Okay, so this is a third recursion relations. So here we are going to use this first and second recursion relations to prove this third one. Okay, so first we know the first recursion relations is equal to l n plus 1 plus x minus 2n minus 1 into ln function of x plus n square ln minus 1 is equal to 0. Okay, this is the first recursion relations. Okay, so by using this first recursion relations, we are going to solve this third ones. Okay, so this first regression relations, if I differentiate with respect to the x, so it is l prime, because this l is a function of x and we are going to differentiate with respect to the x. Okay, so l prime n plus 1 function of x plus x minus 2n minus 1 l prime nx and plus l nx. Okay, after the differentiate this one, so 1 into ln x plus n square l primes n minus. Okay, so this is the first differentiate with respect to the x, first recursion relations. Now again, if I differentiate these things with respect to the x, so it is l double primes n plus 1 function of x, no need to write. Okay, plus x minus 2n minus 1 l double prime is function of x, and the plus here l, this thing if I differentiate, so it is l primes and this is 1, so 1 into l primes and this is l prime, so it is 2 l prime nx. Okay, and the plus n square l double prime n minus 1 function of x. Okay, so this is a second time we differentiate with respect to the x, okay, of this first recursions relations. So now in these equations I am going to replace this n with the n plus 1, okay. So if I replace n with the n plus 1, then this relation become L double prime n plus 2 is function of x plus x minus 2n minus 3 L double prime n plus 1 is function of x plus 2L prime n plus 1 is also function of x, and the plus n plus 1 bracket square L n L double prime n is function of x is equal to 0, okay. So this is we have relations, okay, after just replace with the n with the n plus 1, okay. So now second recursion relation, that is L prime nx minus n into L prime n minus 1 is function of x, and the plus n into L n minus 1 which is function of x is equal to 0, okay. So these things we can write L prime n is function of x is equal to n into L prime n minus 1 which is function of x, and minus L into n minus 1 which is function of x is equal to, okay. This is a left hand side and the right hand side, okay. So this is the L primes we have, and which is equal to n into bracket L prime n minus 1 minus L n minus 1, okay, okay. So these things, now from this second recursion relations I am going to just differentiate these things, okay, with respect to the x. So before that just I put in these equations, that is n is equal to n plus 1. So if I put n is equal to n plus 1, then these relations, okay, so I am going to write here, it is L prime n plus 1 is function of x is equal to n plus 1 into L prime n plus 1, sorry, n is equal to n plus 1, so it is L prime n is function of x minus L n, and which is also function of x, okay. So this is the L prime n plus 1, okay. So okay, now if I differentiate these things with respect to the x, okay, then it is L double primes, or this also we can differentiate with respect to the x. So if I this is from the second recursion relation, and this is for the first, okay. So now this first, suppose this is first equations and this is second equations, okay. So first equations, if I differentiate with respect to the x, so it is L double prime n plus 1 is function of x is equal to n plus 1 L double prime n is function of x minus L n prime x is equal to, okay. So this is L double prime n plus 1, okay. Now here same n plus n I am going to replace with the n plus 1, okay. Again I am for this equation number 3, in the equation number 3 I am going to this n replace with the n plus 1, okay. So if I replace n with the n plus 1, so it is L double prime n plus 2 is function of x is equal to n plus 1, and it is 2 L double prime n plus 1 is function of x minus L prime n plus 1 is function of x, is equation number 4, okay. So we have now L double prime n plus 2, okay, and the L prime n plus 1, okay. So this and L double prime n plus 1. Okay, so now I am going to just, okay, by using this two equations, 3 and 4 equations, okay, if in the equation number 2 I replace this L double prime with the n plus 2, that is L double prime n plus 2, okay, with the n plus 2 into L double prime n plus 1 minus L prime n plus 1, I replace this thing with this thing, okay, and L double prime n plus 1 here I replace with the n plus 1 with this thing, okay. So okay, so L double prime n plus 1, that is equal to n plus 2 into L double prime n plus 1 function of x minus L prime n plus 1 is function of x, okay, into, okay, plus x minus 2n minus 3. Now this L double prime n plus 1 I replace with this thing, okay, so it is n plus 1 L double prime n minus L double prime n, L prime n, okay, and the plus 2 L prime n plus 1 plus function of x, okay. Here is also function of x, this L also function of x, so no need to write it. N plus 1 bracket square L double prime n x. So from this, if I now multiply with this L double prime n plus 1, so here is the n, okay, I am first multiply n plus 2 L double prime n plus 1 function of x minus n plus 2 L prime n plus 1, okay, it's function of x plus x minus 2n minus 3 n plus 1 L double prime n minus L prime n plus 2L prime n plus 1 is function of x plus n plus 1 bracket square L double prime, okay. So here is a L double prime n plus 1, okay, and n into L double prime, so here is a 2n and this L double primes, okay. So if I simplify this all brackets, okay, then we get the relations, that is x L double primes x plus 1 minus x L prime n x plus n into L n x is equal to 0, okay. So it is just multiplications here, all these things, okay. So I am not going to solve all these things. So this is a third recursion relations, x into L double prime x plus 1 minus x L prime n and the plus n into L n, okay. So this is a third recursion relations. So okay, so we are going to stop here. Thank you.